Hello everybody. Welcome to, I guess this is your first circuits lab. And we're a little bit ahead of the class, but I think it's okay. Only by a little bit. This lab is going to include something with capacitors, and it's also going to back up a little bit and talk about Ohm's law. Now, a few things I want to mention right at the start. At the start of this lab, it asks you to define what Ohm's law is and explain it. And I would like everyone to come to the lab having done that. So you can look it up in your physics book. It'll talk about Ohm's law, and you don't necessarily have to fully understand it, but come here already knowing what it says. Then what we're going to do is we're actually going to experimentally verify it. And I'm gonna get you to set up this circuit that I have a picture of it here in black and white, and this is a circuit diagram of this setup. Now, one thing I added to this diagram, and you should add, is put a little arrow. This is your battery symbol. You should put a little arrow through here to indicate that this is going to be a variable voltage source. So we're actually going to access voltage between 0 and 3 volts. This is an ammeter, which is going to measure current. This is a voltmeter. It's going to measure voltage. And this is a resistive element that you will all have. And believe it or not, this is contained in this circuit here. And I'll just remind everybody, you might find it useful to actually bring up the lab through D2L and display the picture in color. Because one of the things I want you to do today is build your first circuit. And I have it built here. It should look a lot like this. But I'm gonna get you folks to build it. It's actually an interesting skill. It's a little bit challenging at first, but it is a worthwhile skill, so I'm going to get you to do that. One thing I'm going to point out, excuse me, is this thing here is actually contained in this thing here and these three dials. And when you get your circuit set up, I will explain that in slightly more detail. But what I will tell you now is that you can take screwdriver just fell. You can take a screwdriver. If you look at the top of this thing, there's actually a slot for your flathead screwdriver, and you can actually, if I can do it here, you're going to be able to just with the screwdriver just turn this, and this is going to allow you to access, these two batteries. They're 1.5 volts individually. I've hooked them together as 3 volts. And by using this, what's called a rheostat, or a variable voltage source, or a potentiometer, you can access between 0 and 3. And we are going to need that today. But again, I'm going to get you to set this circuit up. I will point out that if you look here on this diagram, that's a current meter. And just off to the side here, this is your voltmeter. And these are actually going to hook into your little 550 interface box. So let me indicate how you're going to acquire your data. So let me close this. You're going to fire up Capstone like usual. Da-da-da-da-da. You'll go up to sensor. Actually, you can cancel this and remind me later. You can go to sensor, continuous sampling. This is like before. You can turn off the Wi-Fi because we are hardwired. You will see over here that your sensors are hooked in to these A and B ports. This one here is your voltage. That's A, and this one is your current, if you follow along. The double, the red, black, is voltage, and just the single is for current. So what you're going to do is take your mouse, put it on that first A port, which we know is for voltage. You'll do a left click, scroll down, and somewhere there should be voltage. There it is, voltage sensor. Then you go to the next one. No surprise, you're going to do current sensor. Those are the two that you need. Just a drink of water. You can then close that. And notice, if you can see that, it reads voltage on the horizontal, but this has time. Now we're going to want time in there when we do the capacitor, but for Ohm's law, we want this to be current. So if you put your mouse on where it says time and do left mouse click, I want you to pick current. Now we have voltage versus current. And data collection here is quite simple. We are, again, I have my circuit ready to go. You can go over here and hit hit record. And you're not actually seeing much. Now again, I can turn this with my finger. It's a little bit tight, or again, there's a couple of these floating around and you can do that. It's a little bit easier. So what I'm going to do is, I am just, can't really see, but I am just taking this. This thing actually spins. So I spin it until it hits a hard stop, spin it back, hard stop, and then maybe I'll go forward one more time. And I see a rather boring thing on my screen. I just see a vertical line. But if you go up here and do full screen, boom, look what you have. I have this straight line. And this is voltage versus current. And I have this linear relationship. And that is, and I haven't pointed out, that is for this thing called a resistor. And, you know, if you break, say, an old VCR, that really dates me, or a DVD player, you'll see things like this. They're not much. They've got rings on them. They're color-coded. I have a bunch of other ones over here that we'll use at different times. We're going to use this one for the capacitor. And they just control the flow of current. Now for this, I want you to get the slope of this line. And you've done this before, but if you go up here, there's the fit options, pick linear and close it. And this thing's slope is going to be of interest to you. I don't actually want to tell you right now what it is, but I'm hoping if you come here knowing what Ohm's law is and you're plotting voltage versus current, that you'll have some sense of what that slope is. So that's how you do that. And I don't have the page with me right now. Actually, I do. I'm going to get you to make a sketch of this on here. Doesn't have to be exact, but you can put a few units here just to give scale and indicate, you know, I have already spoiled the surprise a little bit. It's a straight line, but we'll see if you guys will get that also. Now,